I am a student for J Long Futures Academy. Today I'll be covering over Unit 5 of AP Calculus AB, which will be dealing more over the derivative and integral of natural log, or as other people say it, natural logarithmic function, and also natural exponential function. Before I start, I would like to apologize for the bad penmanship of my handwriting, but I'll try in the best of my ability to be more readable. So before we even start deriving or integrating a natural log, first we need to learn some of its properties and also some of its rules, so some of the properties as well when one deals with natural log. So first we have natural log, and it is written as ln. Some people may pronounce it ln. You may hear me use it both ways. So we have ln of x, and it equals to the integral of the function 1 over t dt from the range 1 to x is going to be greater than 0. So it's going to be positive. Now we need to see why ln needs to be used when it's integrating probably an inverse function like you see as 1 over t. So we have the integral, we're integrating 1 over x dx, and so the same thing as integrating x to the power 1 dx. And then when one would usually integrate, one would raise the power. So we have x of 0, and then we do the reciprocal of 0, which is 1 over 0. So we have x to the power 0 over 0, which this is an undefined function, so it doesn't work. That's why we need to introduce ln so the integration can work. So we have the ln of x. Here's how the graph will look like. The domain is from 0 to -8, but it never touches 0. That's why the range is from -infinity to positive infinity. The f is always increasing, and it is always concave down. Okay, now here's some of the ln rules. It can also mean called the log rules. If you guys, pretty sure you guys are familiar with this, we're gonna recap real quickly before we start with integrating. So we have the ln 1 equal to 0. The reason this is because ln is also log base e. So we have ln 1 equals the same thing as log base e of 1. This also the same thing as having the e to the power x equal to 1. What does x need to be to the function equal 1? X needs to be 0. Anything to the power of 0 is going to equal to 1. So that's why ln 1 equals to 0. Okay, now we have the next property, ln a times b. Usually when you have something on the inside right here multiplying, when you separate them, or they're going to be adding. So ln a plus ln b. Same mentality goes with when they're dividing. We have ln a over b. When we separate them, is going to be ln a minus ln b. Now when we have an exponent in here, ln of a to the power n, we would have to bring this power in front. So we have n ln of a. Now here's some examples that deal with some of these rules. We have ln 10 over 9. So that's going to be ln 10 minus ln 9. So that's going to be our answer for this one. Now we have the second one right here. We have ln 6x over 5. First we're going to deal with the division. So we have ln 6 minus ln 5. But since it's multiplying here, we can split that up even more. So we end up with ln 6 plus ln x minus ln 5. That's our final answer for this problem right here. And then we have this third problem right here. Ln square root of 3x minus plus 2. We can rewrite this and have ln 3x plus 2 all to the power of 1/2. So we have that exponent here, so we can take it to the front. So we have 1/2 times ln 3x plus 2. That's our final answer there. And then we go with our final example from this page. We have this is more complex, so it's gonna end up more longer. The type of problems we're gonna be dealing with. These are super basic simple problems, but these ones are gonna That's going to be using all of our ln rules, all of our ln scales. So we have ln of x squared plus 3 squared, parentheses there, over x cube root x squared plus 3. So first we're going to deal with the subtraction right here, which is, we're subtracting because we're dividing, remember that? So we have ln x squared plus 3 all squared minus, put a parentheses, ln x times cube root x squared plus 1. So then we're going to deal with this exponent right here. We're going to bring it to the front. So we have 2 ln x squared plus 3 minus, we can split this up now, but instead of multiplying, instead of adding it, put an addition here, we're going to put it a subtraction. Since when we split them up, we have this subtraction here, so it's going to apply to both of them. So that's why we have minus ln x minus ln x squared plus 1. And then since this is a cube root, we can have the exponent 1/3 right there. So we can now bring that 1/3 in front. So we end up with 2 ln x squared plus 3 minus ln x minus 1/3 ln x squared plus 1. So continue. Now we go to the definition of e. Ln of e equals the integration of the function 1 over t dt from the range 1 to e equal to 1. Another way we can look at this is have also log base e, which is ln, natural log, of e equal to 1, since the base and the function inside here are the same. That's why it's going to equal to 1. When these two, if we have any number or function that's the same here, it's always going to equal to 1. Now here's some of our lns that they don't have e. I mean, they don't apply to we can't do much. We can just, this is a way to check if our calculator works. I already did them here. So we have ln to approximately to 0.69. If you guys have that, then good. ln of 32 approximately to 3.47. ln of 0.1 approximately to negative 2.3. This, it wasn't really relevant. It's just to check to see if our calculators are working. We might be using it later to check our work, to see, mostly with our integration. But let's move on. So now we're going to deal with derivatives now of ln. Now that we covered the basics of ln and e, we're going to continue. So we have the ddx of ln x equal to 1 over x, my bad. And then we have the ddx of ln u. Let u be a function of x that can be derived. So basically u is a function of x. So remember that. So when we're deriving ln of u, first we're going to take the u to the bottom, just put it under 1, and then derive that u. So we have u prime times it, multiplying it. So then we can simplify that, having u prime over u. Remember that this is going to be very critical for deriving a ln with the function inside. So we can see this is true because when we apply it here, we put the x under 1, and then we would do the derivative of x, which is just 1. That's why it is just 1 over x. Okay, now we're going to do some examples of that derivative. So we have the ddx of ln 2x equal to 1 over 2x. Remember, we just put 2x to the bottom, and then we differentiate 2x, which is just 2. So those two just cancel out, so we just having 1 over x. Now we do the ddx of ln x squared plus 1. Again, we take this function, put it under 1, and then we derive this function which is 2x. And now we end up with 2x over x squared plus 1. We can't simplify it any longer. And now with this third derivative, d dx x times ln x. This is a special one because it's going to deal with a product rule. So a product rule, so we basically, you guys we learned that before, or you should have learned that. So we're gonna just go straight forward. The derivative of x is just 1 times ln of x. Just keep ln x just by itself, and then add add just x, just don't do anything to x, and we derive ln of x, which is 1 over x. So if we simplify that, we're just gonna, these x's are just gonna cancel out, so we just have that 1, and then just ln of x just multiplied to 1 is gonna keep it at ln of x, so we just end up with this one. And just so there isn't any confusion, we're gonna flip them, that way that we know that that 1 is not gonna be part of that x, so it's just by itself. So we have 1 plus ln x. And now we have this last one, the ddx of ln x all cubed. This is gonna use a property of the chain rule. You guys should be familiar with the chain rule. So first we derive the outside function, which is the 3. So the power rule, we bring the power down, and then we subtract it by 1. So we have 3 ln x to the power 2, and then we derive ln of x, the inside function, which is just 1 over x, so we can just put the x at the bottom. That's why we just have, if you guys, you can simplify it even more, just having a 3 over x times ln of x squared. It doesn't matter, these two are acceptable answers. So we continue on. And then we go to the back. We're almost done, guys. We have f of x equal ln square root of x plus 1. We can rewrite this again. We have ln x plus 1 all to the power 1/2. Now what we need to do is find the f prime. The f prime is also the same thing as finding the ddx of f of x, so we're going to do the same things we've been doing before. So we have the ddx of ln x plus 1 to the power 1/2. First we're going to deal with the power rule, since it's the outside function. So we bring that half in front, 1/2. We subtract by 1, so we end up with -1 up here. And we keep the inside function by itself, right there. And then outside, we multiplying it with the derivative of ln x plus 1, which is just 1 over x. So once we simplify it, we have just ln x plus 1 to the power -1 half over 2x. And since this is a -1, we can take this down and have a +1 on top and over 2x times ln x plus 1 to the power 1/2. And now our last one, integrating ln. We're gonna be going over this in the next lesson. So we have the integral of the function 1 over x dx from the range 1 to 8. And this also can also be read as the area under the curve of the function 1 over x from the range of 1 to 8. Now first we need to find the integral of 1 over x, since we already know that's going to be ln x. And then we're going to put the range 1 here and 8 away here. And then we do it into this function. We put the first top one, the ln 8, and then subtract it from ln 1. So that way we can find our area under the curve. That's what we're basically going to be doing. And then that's going to equal to ln. We apply to our ln rule. Our ln rule. So we have ln 8 divided by 1, since we're subtracting, it's going to be dividing. So that just leads up with ln 8 approximately equaling to 2.08. And we check if our answer is right. You can plug this into your calculator, and then you're going to end up with the same exact number from here, 2.08. And thank you. This is the conclusion of my video. I'll see you on my next video on 5.2. Thank you.